to do 270-degree rotation. Actually, I'm going to move this because we're going to need some space. But a 270-degree rotation for D would mean a semicircle around point P, and then another fourth of a circle. So point D we'd expect to be somewhere up here. Okay. Or you can think of it like this. You can take point D and just go 90 degrees the opposite direction. They want us to rotate 270 counterclockwise, so we could just go 90 degrees, 90 counterclockwise. Let me see which one's easiest. I don't know, maybe point A, because that looks to be the closest to point P. Let's graph where that's going to be if we go 90 degrees counterclockwise. A is 1, 2, 3, 4, 5 to the right, and 2 up. Anytime we do a 90-degree rotation, we're switching the x and y distances. I went 1, 2, 3, 4, 5 on the x. So to find my new point for A after the rotation, I'm going to switch that 5 from being a horizontal direction to a vertical direction. I'm going up 1, 2, 3, 4, 5. Oh, but I'm not done. It's 5 up, and then it's going to be 2 to the left. And that's because it was 2 to the right. Sorry, it was 5 to the right, 2 up. So I went 5 up, 2 to the left. And I went to the left instead of going to the right because, when you draw a half of a semicircle, if you go a fourth of a circle, should land us somewhere over here, not to the right of point P, but to the left of point P. So that dot is at negative 11 on the x and then 10 on the y. So let's try point D. I'll show you where that rotation ends. Ends this point. We're going 90 degrees counterclockwise. So I'm looking at point P. This is, that's a bad circle. That's a rough sketch of a circle, right? 90 degrees means you go a fourth of that circle. So point D should be right here if we go 90 degrees counterclockwise. So we know D is supposed to be somewhere over here. And we know we're supposed to switch the x and the y units. So to get to D from point P, I go 1, 2, 3, 4, 5 on the x. That means I'm actually going to go 1, 2, 3, 4, 5 up. See how I switch the x and the y coordinates? So if I go 5 to the right to get to point D, that means I need to go 5 up for my rotation. And if I go 1, 2, 3, 4 down, going down is a vertical direction. I need to switch that with my horizontal directions. I need to go 1, 2, 3, 4 to the right. So 4 to the right and 5 up. That puts us at negative 5, 10 for point D. Okay. That's D. That's enough to choose whichever one is correct in Mobius. But one more just in case. Still trying to master, this 90-degree rotation. And just a refresher, 270 degrees clockwise. That's the same as 90 degrees counterclockwise. So point B on the horizontal direction is 1, 2, 3, 4, 5, 6, 7, 8. It's 8 horizontal. It's 8 to the right, 2. We're going to type that. It's 8 right, 2 left. 2 up, I should say. Sorry. To get to point B from our center point P, we go 1, 2, 3, 4, 5, 6, 7, 8 to the right, and 2 up. And if we were to do 90-degree counterclockwise rotation, it means we should be somewhere over here, right? So to figure out exactly what point it is, we're going to switch the x and y directions. Instead of going 8 right, I'm going to go 8 up. 1, 2, 3, 4, 5, 6, 7, 8. That is, if I go 8 up, that's starting at 5. That would put us at 13 on the y-axis. On the x-axis, so we went 2 up to get to B. That means we need to go 2 to the left. Point P is at negative 9, so if I go 2 more to the left, that's negative 11 on the x-axis. So there's our point B. B is negative 11 on the x, 13 on the y. So just remember, 90-degree rotation. Count out where those points are from P, and then switch the x and the y units. Okay. And the final part, to know whether you're supposed to switch going up or down or left or right, use that 90-degree rotation. 90 degrees is a fourth of a circle. So you can draw a circle, through whatever point you're trying to rotate, and then visualize, 2 right angles. That would be a rough sketch of a fourth of a circle for that rotation. Okay, whoops, that's a little off. But okay, that's a fourth of the circle, and that's why we ended up point A in that location.